Hello and welcome guys, welcome to machine learning tutorial, and in this video we will be implementing logistic regression both using NumPy method as well as scikit-learn method. So let's start. So first of all we will go through the NumPy method, and for that let's import the NumPy library. So np. Now we will set some seed. Okay, now we will create synthetic data. So let's say I'm setting m equal to 1000, which will be number of samples. Okay, I want 1000 sample. Generate data. So we'll create x1 equal to np.random .random m comma 1. Okay, just copy this line and paste it again and rename it to x2. Okay, now we need to create bias also, basically or you can say intercept. Okay, x0 equal to np dot once m comma 1. Okay, now we need to concatenate the feature and bias term. Okay, so let's do that. Concatenate okay, so x equal to np dot concatenate x0 x1 and x2. Okay, and let's give the axis to be column. X is equal to 1. Okay, now let's run it. Now if you want to see your x, it look like this. Okay, now what we need to do is we need to generate binary target values. Okay, since this is a classification task, we need to generate target value should be binary. Okay, and here we will create a simple linear decision boundary for illustration. So true weight equal to np dot array -1 2 -1. So just imagine a coefficient for bias x1 and x2. Okay, let me write this comment as well. Coefficient for bias x1 and x2. Now we need our logit. Okay, so for logits will be x dot true weights. Okay, true weights. Now we need to calculate probabilities. Okay, so for probabilities our formula is 1 by 1 plus e to the power logits. Okay, so it will be np dot expression of minus logits. Okay, now for y it will be so this is a decision boundary. Okay, so the probabilities should be greater than 0.05 5, and what we need integer value, right? So for that we need to do as type int. Okay, and it will give either 0 or 1. Now next thing is we have to define the sigmoid function, or you can say logistic function. So for that, def sigmoid, and the formula is 1 by 1 plus np dot expression of minus z. So this is what we have learned in the previous video, that is the theoretical part. So this is the function where we will be feeding the data. Okay, so now we need to define the cost function, or you can say log function, for logistic regression. Okay, so let's define that. Def compute cost, and here we will pass x, y and our theta. Okay, so m equal to length of y, h equal to sigmoid of x dot theta. Now we need a small constant to prevent division by 0. Okay, and for that we need to define epsilon. Epsilon will be 1 e to the power -5. This is a very small value. Okay, So this help to prevent division by 0. Okay, now let's write the cost function. Okay, minus 1 by m into y transpose dot p dot log h plus epsilon plus 1 minus y dot transpose dot 1 minus h plus. Okay, okay, so we are done with the cost function. Now we need to return the cost. So return cost of 0 0. So let me explain what's happening here. So here epsilon, or you can say small constant, added to prevent the division by 0 or taking the logarithm of 0. So this is a numerical stability measure. Then we have log loss. So the log loss is a measure of dissimilarity between the predicted probabilities and the actual value y. Okay, so it quantifies how well the predicted probability match the true binary outcome. So the log loss of logistic regression is defined by this, and minus 1 by m factor scales the cost to be an average overall training example. So the goal during the training process is to minimize the log loss, which essentially means finding the set of model parameter, that is theta, that result in most accurate prediction. And optimization algorithm like gradient descent are commonly used to find optimal parameter that minimizes the cost functions. So this cost variable, so in the logistic regression, it is a measure of how well the model prediction match the actual target value, and it plays a central role in the process of training the logistic regression model. Okay, now let's run it, and let's initialize the weights. Okay, okay, so theta will be np dot random dot randn 3 comma 1. Okay, so now we need to set our hyperparameters. Okay, so it will be learning rate, it will be 0.1, and number of epochs, which will be 1000. Okay, 1000 iterations. Now let's perform the gradient descent. Okay, so for epoch in range of epochs, okay, num epochs. No, so we need to calculate the gradient for each sample and then take the mean. Okay, take the mean after calculating gradient for each sample. Okay, so gradient will be our 1 by m into x transpose dot sigmoid of x dot theta. Okay, and we need to reshape it, y dot reshape minus 1 comma 1. Okay, now let's create theta. Theta will be minus equal to learning rate into gradient. Hope you remember this formula from linear regression implementation of gradient descent when we were doing. Okay, so this is what gradient descent formula is. Now we need to make prediction using trained model. Okay, so let's run it. Sigmoid is not defined. Okay, okay, so we have performed our gradient descent, that is optimization. Now let's make the prediction using trained model. Okay, so predicted probability is equal to sigmoid of x dot theta. Okay, now we need classes. So predicted classes equal to predicted probabilities should be greater than 0.5, and what we need integer value, so as type int. Okay, now let's evaluate the accuracy of the model. Accuracy equal to predicted classes equal to it should match with y. Okay, so reshape, we need to reshape because it is not in the form of a column. -1 comma 1 dot mean. Okay, now let's see the accuracy as well as the coefficient value. Okay, so let's print trend coefficient, that is weights for each of the classes. Okay, this theta, and then let's print the accuracy. So we can see we have our trend coefficient, and we got around 99.8% accuracy. So hope you guys understood how to implement logistic regression through plain NumPy code, and now it is more understandable since we have everything in at hand, and we have experimented this to understand it thoroughly, and now I think we all have a thorough understanding of how logistic regression works. Now for the sake of interest, let me implement the scikit-learn part as well. Okay, so here let's okay, so this was for the purpose of understanding. Obviously this will not be using in your day-to-day life. Obviously you will be using scikit-learn, so let's do the implementation for that part as well. And here we won't be generating any data. We will be using scikit-learn dataset to load the dataset, because scikit-learn already have some sort of dataset already in their library, and we will be importing that library to use for this particular logistic regression part. So let's do that. So first of all, we need to import all the libraries again. So import numpy as np from scikit-learn dot datasets, import load. So we will use iris dataset. Okay, so from scikit-learn dot model selection, import train test set split, sorry. Okay, now from scikit-learn dot linear model, import logistic regression. Now we need to import one more thing, that is accuracy score. So from scikit-learn metrics, import accuracy score. Now let's load the iris dataset. Okay, so iris equal to load iris, x equal to iris dot data, and then our y will be iris dot target. Okay, now let's run it, and you can see what is inside x. You can see that we have 4 columns of data, which means 4 features. And let's see our y, and you can see that it has 3 classes, 0, 1 and 2. So if you ask me what is iris dataset, so the iris dataset is well known and commonly used for used dataset in machine learning and statistics. It is often used for classification and clustering tasks, as it frequently used to help us in demonstrating various machine learning technique. So this iris dataset contain around 150 samples of iris flower, with around 50 samples for each of the 3 species, that is setosa, versicolor and virginica. So you can open kaggle.com and you can search about iris dataset, and you will get to know about whatever what is all this this dataset is all about, and then you can have all the features. So basically each sample consists of 4 features, that is sepal length, sepal width, length, petal width, all measured in centimeter. So the dataset is balanced with equal number of sample for each species. Now the goal of using the iris dataset is typically to classify iris flower into one of the 3 species based on the 4 feature measurement. Okay, so hope you guys understand what is iris dataset. Now let's move to implementation. Okay, so next step is to split the dataset. Okay, split the dataset. X train, X test, Y train, Y test equal to train test split X and Y test size and random state. Okay, we have splitted our data. Now initialize our logistic regression model. Model equal to logistic regression. Here we will pass maximum number of iterations to be 1000. Now let's fit the model. Model dot fit X train and Y train. Okay, now our model is trained. Now let's do the prediction. Okay, make predictions. Y pred equal to model dot predict X test. Now let's calculate the accuracy. Okay, Y test and our prediction. Okay, now let's print the accuracy. So now you can see that we are getting around 97% of accuracy on this data iris data set. Now to increase the performance of this model, what you can do is you can just increase the maximum number of iteration to 10,000. Okay, and copy this whole thing, paste again. Okay, let's run it again. Okay, it's not increasing. So other thing you can do is you can do some feature engineering in this, normalize the data set so that it able to capture what all necessary thing need to be captured. You can create multiple features. You can delete whichever feature is not important, like that whatever discussed in the previous algorithm linear regression. During the implementation of linear regression, we have discussed how to increase the accuracy of any particular model. So those type of thing you can do to increase the performance. So one thing I wanted to add here about 100% accuracy. So a 100% accuracy on a classification problem can be indicative of several possibilities, but it's essential to consider that the context of the data set you are working with. Okay, so if you are getting 100% accuracy, then it is it has some problem. Okay, it's not that your model is good, your model is not good. Okay, to be specifically answer this, it has some problem. What is it? The overfitting. So a 100% accuracy on the test data might suggest overfitting. So overfitting occur when the model has learned to fit the training data too closely and capturing the noise like in the data rather than underlying pattern. So as a result, it performs poorly on new and unseen data. So okay, so hope you understand what that 100% accuracy means. Also there is one more thing where data where you can get 100% accuracy if the data is small and simple like this one. Okay, and well structured, we can achieve 100% accuracy. Might be it will be feasible. Okay, and particularly for linearly separable data, in such case the model can easily distinguish between different classes, which is what happening here. It is allowing us to reach around 97% of accuracy, which is like crazy. Okay, in the real world data set, we won't be able to reach a certain accuracy of 97%. And then what other issues can be if we are achieving 100% accuracy is that if the data set is imbalanced, which means that one class significantly outnumber the other, a classifier that predict the majority class for every sample may achieve a highest accuracy. So in this case, higher accuracy doesn't necessarily indicate a useful model. Okay, so if we are achieving here 97%, that doesn't mean that this model is useful or we can use it anywhere. No, we need to be 100% sure that the model is predicting correctly. Okay, so just to make sure you remember all this thing. That's why I've added few point, because in these these type of data set are prepared. Okay, these are balanced data set, these are not very the number of rows is also less, so these are meant for the purpose of practice. Okay, and that's why we are achieving around 97%, 98%, 99%. Sometime we will see 100% also. So just keep a note of this, and see you in the next tutorial. Thank you so much.